Physics Part 257. Consider a planet of mass m in a circular orbit about the Sun of mass m. If the radius of the orbit is r, the gravitational force F grave between Sun and the planet is F gravitational is equal to gmm over r square. By Newton's law of gravitation, it is force that provides centripetal force as the planet moves in its orbit. So the centripetal force F circ is given by F circ is equal to mv square divided by r, where v is the linear speed of the planet, as has just been stated. F gravitational is equal to F circular. Thus, gmm over r square is equal to mv square over r. The period t of the planet in its orbit is the time required for the planet to travel a distance 2 pi r. It is moving at speed v, so v is equal to 2 pi r over t. Putting this into the equation above, we have gmm over r square. M is equal to 4 pi square and r square, t square, divided by r, or simplifying t square, is equal to 4 pi square gm divided by r cubic. Another way of writing this is t square over r cubic, which is equal to 4 pi square and divided by gm. Look at the right hand side of the equation. The quantities pi and g are constant. If we are considering the relation between t and r for the planets in the solar system, then m is the same for each planet because it is the mass of the Sun. This equation shows that for planets or satellite describing circular orbits about the same central body, squares of the period is proportional to the cube of the radius of the orbit. The relation is known as Kepler's third law of planetary motion. Johannes Kepler, 1571-1630, analyzed data collected by Tycho Brahe, 1546-1601, on planetary observation. He showed that observations fitted a law of t square r, and it went all along with it. In fact, the orbits of the planets are not circular but elliptical, a fact recognized by Kepler. The derivation of the simpler for the case of a circular orbit. Table collects information about T and R of the planets of the solar system, and they are provided here. The table collects information T and R for the planets of solar system. The last column shows that the value of T square over R cubic is indeed constant. Moreover, the value of T square divided by R cubic agrees very well with the value of 4 pi square divided by gm into 2.97 into 10 powers raised to minus 25 years per meter. We've got planets: Mercury 0.24, 557.9 into 10 power raised to 6, then 29.1 into 10 power raised to minus 25. Well, I can give the list of all these planets. Number 1, Mercury. Number 2, Venus. Number 3, Earth. Number 4, Mars. Number 5, Jupiter. Number 6, Saturn. And number 7, Uranus. Number 8, Neptune. And number 9, Pluto. Well, when it comes to time Earth years, the largest one is that of Pluto, 248. And the shortest one is that by Mercury, 0.24. And so does it go along for the time scale r cubic year per meter. 2.99 into 10 power raised to minus 25 for Mercury, and 2.99 into 10 power raised to minus 25 for Pluto.